This is the Precalculus Spring 2015 ACP Study Guide, problem 29, which is a problem on Newton's Law of Cooling. And I'm not exactly sure the problem is in the format stated here exactly, but a Newton's Law of Cooling problem is on the exam. And Newton's Law of Cooling, this is probably, if the problem is in this format, it's going to be a bit of a complex problem in that we have to make two uses of this equation in order to find a solution. And you're going to see pretty quickly what that amounts to. If we put the final temperature, in the instance we're given is that the egg that is put in water taken out near boiling at 96 degrees centigrade. 100 degrees centigrade is boiling at sea level, so this might be boiling at a little bit of elevation. So we have our final temperature, which is 45 degrees centigrade, equals the temperature of the medium, which is 16 degrees centigrade. And so that's the temperature of the water, the cool water that the egg is placed into, plus the difference of our final temperature, which is 96 degrees centigrade, and our temperature of our medium, and then E to the power of negative KT. Well, we're going to put negative K, and then for T, we're saying T is 4 minutes later. So negative K times 4. Negative K times 4. And so we can solve this equation by isolating E to the negative 4K, and then taking the logarithm of both sides and so forth. But for this, this is a good opportunity to use in the TI-Nspire CX calculator something we call NSolve, standing for numerical solve. To get to that operation, you press menu, and we go to 3 algebra, and then press enter for numerical solve. So the equation is 45 equals 16 plus, open parentheses, 96 minus 16 times E to the power of negative, we'll say 4x. Remember we had negative K times 4, we'll say 4x. And then we go to comma x. So we just kind of double check, make sure everything is right. It looks like it's right. And we press enter, we get a K value of 0.253683. So we go here and write down K equals 0.253683. And then we're going to cycle through in this equation again. This time we're going to try to find out T, knowing what K is, for the egg to cool down to 20 degrees centigrade. So I'm going to come down here to the left a bit and put down the new instance, which is 20 degrees. It's equal to 16 times, we have same thing, oh, excuse me, it's plus, and I'm going to put in here, let's put 96 minus 16. We have E to the negative, and we have 0.253683 T for time. So this equation we'll use to solve for time, knowing what K is. Some of these equations are to the power, E to the power of KT or negative KT. If this thing was just KT, then K would be negative 0.253683. So we go back to our calculator using the same thing, but we have this time 20 equals, we have our temperature of our medium 16 plus, open parentheses, 96 minus 16 is 80, so we'll just put 80, and we'll put E to the power of negative I'm going to put ANS. To do that, I'm going to press Control, negative sign, and we're going to put times X. And then we're going to come down and press comma and then X. So let's go ahead and work that out. Syntax. What is happening here? I don't know if they're getting me for ANS. I'm going to go ahead and try that again here. Okay, Control. Escape. Come back. Okay, algebra, numerical solve. Let me back up here. Maybe it doesn't like my ANS. Okay, numerical solve, menu, algebra, 1. So we have 20 equals 16 plus 80 e to the negative 0.253683 times x, and we come here and we press a comma, and then we'll solve for x. And let's see if we get it right this time. Yes, we get 11.81 minutes. So we go back to our answers, say t equals 11.81 minutes, and we see that B is our correct answer. Now, alternatively, we could, I'm not going to go through it all, we've taken enough time in this video lesson, but if we subtract 16 and divide by 80, all right, we could do this. If we subtract 16 from both sides, we're going to get 4 equals 80 e to the negative 0.253683 t. We divide by 80, we'll get 4 over 80 equals e to the negative 0.25683 t. And then if we take the logarithm of both sides, on the left side we would get the natural logarithm of 4 over 80, which I think reduces to, I'll just put, it's going to be 1/20th, right? The natural logarithm of 1/20th equals, you take the natural logarithm of e, you get negative 253,683, excuse me. 253,683 t. And so if you divide by negative 0.253683 by both sides of the equation, that cancels, so you're going to get the value for t, and this is supposed to be up here, 253,683. So anyway, good luck with that, and thank you for viewing.